Okay, this is again 2007 BC. This is Form A, and this is the number 6. And they tell you that f of x equals e to the negative x squared. So first of all, they want you to find the first 4 non-zero terms for the general term of the Taylor series for f about x equals 0. Probably should say up here that f of x equals e to the negative x squared, okay? So rather than figure out all the derivatives, we can just build this off of our e to the x series, and we know e to the x is 1 over 0 factorial plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the n over n factorial. And there's your summation for all x. Okay? It's the interval of convergence. It's all x. So that's a nice one. So we're going to get the value for e to the x. And so so e to the negative x squared, that's what we want, that polynomial, is we're just, every time we see an x, we put negative x squared. So 1, nothing there, plus negative x squared, plus negative x squared squared over 2 factorial, plus negative x plus negative x squared cubed over 3 factorial, and then negative x squared to the n over n factorial. And then we can simplify that a little bit. And they ask for the first 4 non-zero terms and the general term. So we have x minus x squared plus x to the 4th minus x to the 6th plus and then if we square that, that's going to be like a negative 1 to the n I can put out here, and then x to the 2n all over a factorial. And this is nice because it tells me that I have an alternating series, so that's going to be important because we really like those alternating series. Okay, letter B. Okay, and again, you're going to have to look off your, I didn't write the question here, you can look off your question. This is letter B. Use your answer in part A to find the limit as x approaches 0 of this 1 minus x squared minus f of x over x to the 4th. Well, I called this g of x just for convenience, and I wrote that g of x equals, and I can take the 1 over x to the, I can take the x to the 4th out in front, and I've got this 1 minus x squared, and then what is negative f of x? Well, f of x is right up here. So if I take its negative, that's going to be negative 1 plus x squared minus x to the 4th over 2 factorial plus x to the 6th over 3 factorial. The next one would be minus x to the 8th over 4 factorial all the way out. And I didn't really do the general term because you don't really have to when you'll see in just a moment. But 1 minus 1 is 0, negative x squared plus x squared is 0, so this is all I have left. Times 1 over x to the 4th. So if I divide each of these by x to the 4th, that just becomes 1/2. That becomes x squared. This becomes x to the 4th, all the way out. Now I want to take the limit as x approaches 0. Well, notice that all these terms have an x in them except for the first term. So if I'm taking the limit as x approaches 0 of g of x, that's the limit of this. This goes to 0, that goes to 0. All these other terms go to 0 because they all have x's in them except for the first term, and that's negative 1 over 2 factorial, which is negative 1/2, so there's your limit. That's all. Okay, so that was pretty easy, I hope. All right. Next, letter C. Write the first 4 non-zero terms of the Taylor series for this integral, the integral from 0 to x of e to the negative t squared dt about x equals 0. It's okay when it's about 0. If we have some other numbers, then sometimes you have to use a kind of a u substitution. But this is okay because it's a lot of, really like a Maclaurin, so it's around 0. So this is good. So they want you to write this integral. So that's going to be the integral of 0 to the x instead of e to the negative t squared. This is my function, right? E to the negative x squared, so t is just the dummy variable. And then when I take the antiderivative of each term, I don't just have to worry about the 4 terms. I got t squared over 3, t to the 4th, I'm sorry, t cubed, pardon me, t cubed over 3, t to the 5th over 5, and 5 times 2 is 10, and then minus t to the 7th over 7, and 7 times 6 is 42. And we can just carry that out, that integral, but we just really want the first 4 terms, so I just carry it out a little bit like that. I take that integral, and they want to write the first 4 non-zero terms, and then it kind of goes out there. And then they want us to use, so this is the integral, and then if I make the substitution, I'm sorry, so these were the first, this is out to 4 terms, but it keeps going. But if we put 0 in here, all these zeros are going to drop out, and then I can put x in here, and this is what I get. X minus x cubed over 3 plus x to the 5th over 5 plus x to the 7th over 42 plus, and that's the actual integral. It keeps going out there. But we showed the first 4 non-zero terms, but it does go out. Okay? All right, then they want us to use the first 2 terms to estimate the integral from 0 to 1/2. So that's just going to be 1/2, and then minus, and then I just made this 1/3 times x cubed because I'm going to have 1/2 cubed, so I have another fraction. So that was just to make it tidy. And that's going to be 1/2 minus 1/3 times, and then 1/2 cubed is 1/8. 1/8. So that's going to be 1/2 minus 1 over 24. And 1/2 is 12 over 24 minus 1 over 24 is 11 over 24. So that was your approximation. Okay. And letter D, explain why the estimate found in part C differs from the actual value of the integral from 0 to 1/2 of e to the minus d dt by less than 1 over 200. Well, we're looking for the error. Now, we don't have to do the Lagrange error bound because this is an alternating series. And remember, when we have an alternating series, and it's going to converge because it's decreasing. Okay, it's an alternating series, all right? And you can tell that it's decreasing. You can tell that these terms are positive, so, you know, and, but it is decreasing. So you can tell that it's an alternating series. Then the error in the approximation will be the first unused term. So we're using the first 2 terms to make the approximation. So the first unused term is this, and that's going to be my error. That's as simple as that. So if we're using 2 terms for an alternating series, the third term is the error bound. So my actual value minus my approximation will be less than the third term. And that was going to be 1/2 to the 5th over 10. Evaluate it to 1/2. That's it. That would be the third term. So 1/10 times 1/2 to the 5th is 1/10 times 1 over 32, which is 1 over 320. And 1 over 320 is smaller than 1 over 200 because the denominator here is bigger than this denominator, so that makes this fraction smaller than that fraction. Okay? So it's just the first unused term of an alternating series. Okay? Hope that helps.